Hello everybody, welcome into another lesson. So today we are going to factor the difference of two squares. Now, what we're going to do only works if you have the difference of two squares. So, for example, we have b squared minus 36. This is a perfect square binomial, which is what we're going to be factoring today. In order to take the factor of this, what you do, you take the square root of b squared, which would be b, and then 36, one root of it is plus 6, and then you would do that quantity times b minus 6, because the square root of b squared is b, and then the roots of 36 are plus and minus 6, because you have two roots for plus or minus 6. You have for 36. So when you have the difference of two squares, you take the square root of the variable, then plus or minus the square root of the number that's present. So you get b plus 6 times b minus 6. So now let's say the problem had been something like this. What if we had the sum of two squares? Well, this is not taught in Algebra 1 because that involves the use of imaginary numbers. So this type of thing we won't learn until Algebra 2. So that's not until Algebra 2. We won't do the sum of two squares. That's when we learn imaginary numbers, is in Algebra 2. So for now, if you come across the sum of two squares, there's no answer for it for now. For now, at least. Alright, let's see here. Let's say we have the perfect square binomial of m squared minus 25. So we have m squared minus 25. Well, start a parenthesis, take the square root of m squared, which would be m, square root of 25, that's plus 5. Then you also have m minus 5, because then you have negative 5 as a square as a root of 25 also. So what you're going to get is the quantity of m plus 5 times the quantity of m minus 5 for your factorization of m squared minus 25. Alright, now let's say you had something like 4c squared minus 81. All of a sudden, the coefficient on the variable is no longer 1, it's something other than 1. Well, start out by taking the square root of 4c squared, that would be 2c. Then the square root of 81, that'd be, you have positive 9, so you have 2c plus 9. And then you have another parenthesis, you also have 2c for the square root of 4c squared. Then you have negative 9 for a root of 81 also. And the idea is that if you were to FOIL your answer out, you would get the original expression. So if we go through and FOIL out, or we do the FOILing here, you would in fact get 4c squared minus 81. So the answer you should get for this is the quantity of 2c plus 9 times the quantity of 2c minus 9. Alright, we have the quantity of 9a squared minus 100. Okay, so 9a squared minus 100. Well, what we have to do is first take the square root of 9a squared, that'd be 3a, plus the square root of 100, that'd be 10, times the quantity, you do another 3a, then minus 10, because negative 10 is also a square root of 100. So you always start out with the root of your first term plus the root of your second term, that quantity times the root of your first term minus the other root of your second term. So the answer you should get is the quantity of 3a plus 10 times the quantity of 3a minus 10. Alright, here, let's see. We have 25z squared minus 1. So we got 25z squared minus 1. What you have to do here is take the square root of 25z squared, which would be 5z, then plus the square root of 1, well, that's positive 1. Then you do that times the quantity of 5z minus the square root of 1, which would also be 1. So you're going to have 1 plus the root and then 1 minus the root every time for your second term. So you'll get the quantity of 5z plus 1 times the quantity of 5z minus 1. Alright. We got 16x squared minus 9. So 16x squared minus 9. We'll start out, we'll take the square root of 16x squared. Well, that'd be 4x. Plus the square root of 9, that'd be 3. Times the quantity of also 4x. Minus the square root of 9, which would be 3. So you'll have 1 plus and 1 minus the square root of the second term. So the answer you should get it for the factorization of this is 4x plus 3, that quantity, times the quantity of 4x minus 3. Alright. Now what if we had a problem like this? 1 minus 9a squared. What if we have 1 minus 9a squared? Well, it's always going to be your first term remains positive. So the square root of 1 is 1. Now the square root of 9a squared, that's positive, that you'd get positive 3a. Then you would do the quantity times 1 minus the square root of 9a squared, which would be minus 3a. So your first term, in the original equation, the first term always remains positive. Your second term is where you do the plus and minus the square root. So if you have a situation such as that, the first term always dictates and will be positive. Your second term will always be the plus or minus the square root of the second term. So you should get 1 plus the quantity, 1 plus 3a, that quantity, times 1 minus 3a. Do another problem like it. Let's say we have 144 minus y squared. So we have 144 minus y squared. Well, the first term is 144, so that's going to stay positive. You're going to take the square root of 144, which is 12, plus the square root of y squared, which would be y, times the quantity of, again, square root of 144 is 12, minus the square root of y squared, which would be y. So the prime factorization, the factorization you should get for this binomial is 12 plus y, that quantity, times 12 minus y. Alright, let's change it up a bit. We have 49a to the second minus 9b to the second. Now all of a sudden we have a variable in both terms. Well, we're not going to do this any differently. Since we got the first term being 49a squared, that square root's going to remain positive since that's the first term. So the square root of 49a squared would be 7a plus the square root of 9b squared, which would be 3b. That quantity times, again, your square root of 49a squared, which will remain positive, that'd be 7a, minus your square root of 9b squared, which would be 3b. So the factorization you should get for this is the quantity of 7a plus 3b times the quantity of 7a minus 3b. And again, if you're unsure if you got the right solution, just FOIL this out, and if you got the original equation, you got the right factorization. So that's a way you can check it. Alright, 64 u squared minus 25 v squared. So we got 64u squared minus 25v squared. Well, since 64u squared is the first term, the square root of that will remain positive. So the square root of 64u squared, well, that's 8u, plus the square root of 25v squared, that'd be 5v. So you got that quantity times the quantity of, well, you got the square root of 64u squared, that's going to be 8u, minus the square root of 25v squared, that'd be minus 5v. So the factorization answer you should get is the quantity of 8u plus 5v times the quantity of 8u minus 5v. Alright, now what if we had something like this? We have 16 minus c to the fourth. Well, all of a sudden it's not to the second power anymore. Well, the process starts the same. You're going to keep your first term positive. So the square root of 16, that's going to be 4. Plus the square root of c to the fourth, well, that would be c squared, times the quantity of the square root of 16, which is 4, minus the square root of c to the fourth, which would be c to the second. Well, 4 plus c squared doesn't break down any further because that's the sum of two squares. We can't do anything with that right now. We're not in Algebra 2 yet, so we can't do anything with that. But we can, however, factor 4 minus c squared further. What you're still going to have is the quantity of 4 plus c squared, which could be left alone, times, now you got 4 minus c squared. 4 is your first term, that'll remain positive, so square root of 4, that's 2, plus the square root of c squared, which is c, times the quantity of the square root of 4, which is 2, minus the square root of c squared, which is c. And we can't expand this any further, so the answer you should get for your factorization is the quantity of 4 plus c squared times the quantity of 2 plus c times the quantity of 2 minus c. Alright. We have 625 x to the fourth minus 1. So we got 625 x to the fourth minus 1. Well, Still, let's take the square root of 625, which would be 25. Square root of x to the fourth, that's x squared. So you get 25x squared plus the square root of 1, which is 1, times the quantity of, again, 25x squared minus the square root of 1, which would be 1. Well, we can't factor 25x squared plus 1 any further, at least not right now. But we could factor 25x squared minus 1 further. So what you'll have is the quantity of 25x squared plus 1 times, now we're going to do the factorization of 25x squared minus 1. So take the square root of 25x squared, that would give you 5x, plus the square root of 1, which would be 1, times the quantity of 5x minus the square root of 1, which would be 1. So the answer for the factorization you should get would be the quantity of 25x squared plus 1 times the quantity of 5x plus 1 times the quantity of 5x minus 1. Alright, let's see here. U to the fourth minus 81v to the fourth. So we got u to the fourth minus 81v to the fourth. Well, since u to the fourth is your first term, the square root of u fourth will stay positive. So the square root of u to the fourth is u to the second, plus your square root of 81v to the fourth, that would be 9v to the second, times the quantity of u to the second minus your square root of 81v to the fourth, which would be 9v to the second. Well, we can't factor u squared plus 9v squared any further, but we can certainly factor u squared minus 9v squared further. So let's go ahead and do that. You'll still have the quantity of u squared plus 9v squared. Now, let's do the factorization of u squared minus 9v squared. Square root of u squared is u plus the square root of 9v squared, which would be 3v, times the quantity of u minus the square root of 9v squared, which would be minus 3v. So the factorization you should get for this problem would be u to the second plus 9v squared, that quantity, times u plus 3v, times the quantity of u minus 3v. All right. 81 s to the fourth minus 16 t to the eighth. Alright, so we got 81 s to the fourth minus 16 t to the eighth. Well, what we can do here, we still take the square root of 81 s to the fourth, that'd be 9s to the second, plus the square root of 16t to the eighth, which would be 4t to the fourth. That quantity times the quantity of 9s squared minus the square root of 16t to the eighth, which would be 4t to the fourth. Well, we clearly can't factor 9s to the second plus 4t to the fourth anymore. We certainly can't do that. But we can definitely factor 9s to the second minus 4t to the fourth. So let's go ahead and do just that here. You'll still have your quantity of 9s squared plus 4t to the fourth times, let's see here, square root of 9s squared, that's going to be 3s, plus the square root of 4t to the fourth, that'd be 2t to the second, times the quantity of 3s minus the square root of 4t to the fourth, that'd be 3s minus 2t to the second. And none of these factor any further. So the factorization you should get for this problem is the quantity of 9s to the second plus 4t to the fourth times the quantity of 3s plus 2t to the second times the quantity of 3s minus 2t to the second. Alright, couple more, then we're done. Two more examples. We have x to the eighth minus y to the eighth. So x to the eighth minus y to the eighth. Well, we are going to still do it like we've been doing. Take the square root of x to the eighth. That'd be x to the fourth. Plus the square root of y to the eighth. That'd be y to the fourth. Times the quantity of x to the fourth minus the square root of y to the eighth, which would be y to the fourth. Alright, well, we clearly can't factor x to the fourth plus y to the fourth any further, at least not right now. But we can factor x to the fourth minus y to the fourth. That's a difference of two squares. So we're going to keep the x to the fourth plus y to the fourth times the quantity of, what's the square root of x to the fourth? Well, that'd be x squared plus the square root of y to the fourth. That'd be y squared times, you would get x squared minus the square root of y to the fourth, which would be y squared. Well, we can't factor the x to the fourth plus y to the fourth. We also can't factor x squared plus y squared. But we still have a difference of two squares where we have x squared minus y squared. We can definitely factor that. So we're going to keep the x to the fourth plus y to the fourth times the quantity of x to the second plus y to the second. Now, times the quantity of, what's the square root of x squared? Well, that'd be x plus the square root of y squared, which would be y, times the quantity of x minus the square root of y squared, which would also be y. So the factorization you should get for this problem would be the quantity of x to the fourth plus y to the fourth times the quantity of x to the second plus y to the second times the quantity of x plus y times the quantity of x minus y. And I got one more problem. Fun one. We got m to the 16th minus 1. Alright. So we got m to the 16th minus 1. Well, we'll take the square root of m to the 16th, which would be m to the 8th. That would be m to the 8th plus the square root of 1, which would be 1, times the quantity of m to the 8th minus the square root of 1, which would also be 1. Well, it's clear that m to the 8th plus 1 factors no further, but m to the 8th minus 1, that's also a difference of two squares. That'll factor further. So let's go ahead and do that. We'll keep the quantity of m to the 8th plus 1 times our new quantities. The square root of m to the 8th, that's going to be m to the 4th, plus the square root of 1, which would be 1, times the quantity of m to the 4th minus the square root of 1, which would also be 1. Well, now we can't factor m to the 8th plus 1. We also can't factor m to the 4th plus 1, but we can factor m to the 4th minus 1 since that's a difference of squares. So let's go ahead and do that. We'll keep m to the 8th plus 1 times the quantity of m to the 4th plus 1. Now, the square root of m squared, m to the 4th, that'd be m squared, plus the square root of 1, that'd be 1, times the quantity of m squared minus the square root of 1, well, that'd be 1. So we also can't factor the m squared plus 1, but we can factor m squared minus 1. That's a difference of squares, so we'll go ahead and do that. You'll still have your m to the 8th plus 1 times the quantity of m to the 4th plus 1 times the quantity of m to the 2nd plus 1. Now the square root of m squared, that's going to be m, plus the square root of 1, which is 1, times m minus the square root of 1, which is also 1. So the answer you should get for your factorization of this problem would be the quantity of m to the 8th plus 1 times the quantity of m to the 4th plus 1 times the quantity of m to the 2nd plus 1 times the quantity of m plus 1 times the quantity of m minus 1. So remember, your first term always dictates what stays positive. Your first term will always stay positive in your parentheses when you're doing the factorization. You just take the square root of those and it'll repeat in each parenthesis. Then you do plus and minus the square root of the second term, and that's really all there is to it. So next lesson we're going to do squaring of binomials. We're going to square them. We're going to raise them to the 2nd power. There is a shortcut for that. So I hope everybody has a good night. Take care.